Oh, shared the wrong screen. Just a second here. Okay. So I'm supposed to give an overview of WMS and how you would use that to set up a GSHA model. And so that's what I'm going to do. I had some slides, but I don't know that I'm going to go through the slides. I think instead of that, I'm going to instead show you how you would set up a GSHA model in WMS, or at least how I do it. And you can, that way you'll know actually how it's used. So just a quick overview of WMS. This menu, this thing at the top is the menu, of course, and that menu is going to change. So these icons here are the different modules. The menu changes depending on which module you select. So there's module specific menus. These icons over here at the left are the tools. Those tools will also change depending on which module you select. And then there's some other stuff. So this window over here on the left is called the Project Explorer. So any data that you have in WMS, it just shows up in this Project Explorer. And when you start up WMS, there's going to be some default data inside of WMS. You can see it right here. And then when you add data, it's going to show up, as you add data, this data is going to show up in this window here. And then you can right click on different things, and there's going to be options to delete different items and things. Everything else is just what we call macros. So these are just little different quick ways to get to tools. Those macros are also, you can get to most of those things in the menus up here. And then these are also macros over here. These are some macros and so on. This window over here on the right is the properties window. So anything, the main window is just this big blank area in the middle. That's called the graphics window. And that's where you're going to do all your work. And then over here on the right, if I select something in that graphics window, it's going to show the properties of that over here in the properties window. And then there's some tools down here at the bottom. Those are called annotation tools. So that's kind of an overview of the WMS window. So I want to get started. Let's just set up a GSHA model. So to do that, what I usually do is, the easiest way really is to go to the Hydrologic Modeling Wizard. So if you're just starting out, you can click on this button. It's a little wizard hat with, it's on top of a tree, like a little tree icon that looks like one of these tree icons right here. We call it a hydrologic tree. And that wizard hat is the Hydrologic Modeling Wizard. Let's click on that icon. That's going to bring us into the wizard. And the first thing you do when you set up a model is you specify your file name. So I'm just going to put in a file name here. We're going to call this I'm going to make a folder here called demo. And then in demo, I'm going to make a folder called, call this Judy's, or Judy's branch. And I'm going to call this file Judy's branch.wms. And then we'll just save that. That's not really going to save anything because I haven't done anything yet. That's just to define my project file name. The next thing is you can define your projection. And for my projection, I'm going to select a projection called UTM Zone 15. And there's a lot of different UTM Zone 15s. The one I'm going to select is this NAD 83 UTM Zone 15 North. And that's the projection I'm going to use for this project. And we're going to define so you define your horizontal, your X and Y units, your horizontal units. are defined with this projection. And it's kind of hard to tell actually, but one of the last things in this, all this gibberish that you see here, it says unit and it says meters here. So this projection is in meters. I'm also going to change the Z unit, so those are in meters also. And then we're going to hit OK. And by the way, you want your GSSHA model to be in meters, your X, Y, and Z units to be in meters when you create your model. And so just keep that in mind. And then I define my project boundary. So to define my project boundary, I'm going to click on this define button. It brings up this map locator tool. And I'm just going to type in Judy's branch. And let's see, maybe I need an apostrophe. Okay, Judy's branch. And I'm going to select this one in Illinois. And so that'll take me to Judy's branch. And this is kind of the watershed area. If you zoom out here a little bit, you can kind of see this is St. Louis, Mississippi River right here. But then there's this area that's, there's a little creek here called Judy's Branch. If I zoom in enough, you can kind of see it maybe a little bit. But we're going to model this Judy's Branch watershed. And so I'm just going to select that area, hit OK here. And then that defines my coordinates for the area that I'm interested in modeling. The next thing I'm going to do is I'm going to use web services to download some data that I need for the watershed modeling. So there's a lot of different data sets available, and some of them are not available in this window. But the ones I'm going to use this USGS 3DEP, 3DEP is what I call it. It stands for 3D Elevation Program. And what the USGS has done, they've gone and collected some LiDAR data for most parts of the United States, and then they've combined it into a seamless data set. And that's what that is. I'm also going to need some land use and soils data if I'm going to do a valid GSSHA model. So I'm going to do land use. Actually, I'm going to use the NLCD 2011 data. And this actually goes up to, I think 2021 is the most recent, but that 2021 is not available in this window. There's another way to get to it in WMS. And then I also want the soils data, which the soils data I want is a Surgo soil data. That's the most accurate that I can get for this area. So I'm going to click on those things, download the data. It's going to ask for a raster cell size. We're going to use the default there, 12 meters. And so that's for the first one's for the elevation. This is for the land use data. I'm going to use 20 meters for the land use data. That means it has a point. So I have an elevation point every 12 meters and a land use point that tells me what the land use is every 20 meters. And then it also downloads some Surgo data, which is just soils. So if we move this out of the way, you can see here what it's downloaded is some soil data. That's this little shape file here. And if I zoom in, you can kind of see that a little bit better. It's just some soils. And I'm going to turn that off because it kind of clutters up the screen. It's also downloaded some land use data. That's these pixels here. That's land use information. It has different land use data values for every 20 meters in this area. And I've also downloaded some elevation data. That's what this is the elevation data. And so you can look at that if you want. And one thing I need to do with this elevation data, if I want to use it for watershed modeling in WMS, I need to convert that to a DEM. So I'm going to right click and select convert to DEM. And just hit OK there, just use the defaults. And that's going to create a DEM from that. And so what WMS does when I do that is it creates this DEM up at the top, and it creates, you can see the DEM, it's just these contour lines are from the DEM, and I can turn off this is the data, the the elevation data that I downloaded, and I converted that to a DEM and WMS. And you don't need to necessarily worry about all the different steps, but just kind of, you don't need to write anything down, but I'm just giving you an overview of how you'd use this. And so the next thing I need to do after I've gotten that elevation data, I can run Topaz. What Topaz does is it gives me the potential locations of streams in this area. So I'm going to run Topaz, and like I say, I'm stepping through this wizard, and Topaz gives me these blue lines, and these blue lines represent where the streams could potentially be located. It shows me areas where there's a high amount of flow accumulation based on my elevation data, and then I can see those areas. And then the next thing I need to do is create an outlet point. And before I do that, I'm going to just bring in a background image so we can see where we are. I'm just going to bring in a Google map. And to do that, I just clicked on this button up here so we can kind of see where we are. And what we're interested in is this Judy's branch here. I think this is it. This little creek right here is Judy's branch. And we're going to just create an outlet point right here. Maybe we'll put it where this stream intersects the road here. And then I'm going to go ahead and click on this delineate watershed button. I'm going to change this threshold value to 1 square mile just to make things a little bit easier for me. And then I'm going to delineate the watershed. So that 1 square mile, that just means I need 1 square mile of flow accumulation to create a stream arc in my GSSHA model. And let's see, got a lot of clutter here. Let me turn off some of this stuff. So this, I have some drainage data that I have turned on. I'm just going to turn off that drainage data, and that'll get rid of that. Okay. Then what I do is define my model. So the model, there's a bunch of models that WMS supports. The model we're talking about, of course, in this course is GSSHA. So I'm going to click on this initialize model data. And then we're going to create, you can create streams. And streams are a little bit tricky to see those set up. What GSSHA has inside of it has a 1D hydraulic model as part of the interface. So you have to carefully define those streams so they are in sync with the overland flow. And for this particular model, I'm just going to say I have a bunch of trapezoidal channels. We're going to define some 0.03. We're going to define some Manning's roughness values, a depth of maybe 1 meter, bottom width, we're going to do 3 meters, side slope, we're going to just do 1 to 1. And then there's some other things, but that's what I'm going to do for all these channels. And it's going to tell me it needs to define some numbering here for those streams. Then I'm going to redistribute the vertices. This just kind of smooths out the stream locations. And I'm going to do that. Hit OK. And then there's this kind of tricky step where you have to smooth streams. You don't need to worry about this because there's tutorials. But I'm going to quickly smooth out these stream locations for this model. And as you can see, they're pretty jagged just because of my elevation data. But I'm just going to smooth those out. And then just got a few more streams to do here. And we're going to go in and smooth these streams out also. Just so, because I need my water flowing downhill on those streams. And so if I have all those jagged streams, it's going to cause problems with my hydraulic model part of GSSHA. Okay, so that my streams are all smooth. The next thing I do is define my grid. And to do that, I'm just going to use a grid cell size of 90 meters. And we're going to create the 2D grid. And then we're going to define a time, start and end time for my model. We're going to start maybe at 12 noon, 9, 10, yeah, whatever. And then 12 noon, we'll go to, well, let's go to 2 days later. So we're going to go 9, 12, go to 12 noon. And we just set that, click on the set job control data. That sets some GSHA parameters where it starts and ends at these times. And it'll run for 2 days, basically, for this model. Now, I have some soils data, and let me just show you how this works. So I need to join some attributes, but what you can do is in WMS, you can create this soils coverage, and the soils coverage is going to have the soil texture. So it looks like all of this whole area is silt loam soil texture, and it's going to have that soil texture that you can then use that soil texture to define the different soil types and infiltration parameters for your GSHA model. And the other thing you can do is you can use the land use combined with the soil texture to determine those infiltration parameters. I'm not going to worry about all that and go through all that. It's too much work for this demo, but what I'm going to do is I'm going to create, let me just show you kind of how you might use that. So you can create what's called an index map, and that's just on each cell in your grid, you can define an index value. Let me show you how that looks. So like if I use a soil texture and I create this index map, let's go and look at my index map that I just created. Let me turn off some of this stuff. So my index map is, and actually I think they're all the same soil texture. So it's going to, these are all the same values. So like if I click on any cell here, it has, oh yeah. So it has that index map ID. They're all 17. And that's just the ID that we use for that soil texture. I'm not sure why it's 17, but that just means everything has the same soil texture. And you could actually, let's see, you could change these contours, these index maps. So it looks like there might be some values of 12. I don't know. I don't see it. Oh, there might be some other values, some other soil textures up here in the upper part of the watershed. That's the red values, but everything else is kind of that greenish value. Anyway, so I have two different kinds of soils, two different soil textures, and then I can use those soil textures then when I go here to my what's called a mapping table. I can use that index map to define something like infiltration. And like if I wanted to do this green and amped infiltration, you can then generate IDs and it'll have silty clay loam, which is 12, and then 17 is silt loam, and you can put in values, which like Aaron mentioned, you can go to that one of those tables on the GSHA wiki and get these values that you need to fill in these values here in this table. And then that basically defines all the infiltration values you need for your GSHA model. And then, but I'm actually not gonna do infiltration for this particular model because it's it's beyond the scope of what I'm trying to tell you here. What I'm gonna do is just the main thing you need to just get a GSHA model running is you need to define roughness and for each grid cell. And so I'm going to use, actually, let me go back here. What I can do for that is I can use this data calculator and just create a uniform index map. I always like to have a uniform index map when I'm first starting out, and just define an index map where everything just has a value of 1. And I'm going to create that. And so you can see that everything is red in this window. That means all those values have a value of 1. All these cells have a value of 1. And then I can then use that for my roughness value. So I'm going to use this uniform index map. And everything just means everything has the same roughness value. Just to start it, I'm going to be 0.1 for my surface roughness there. And so, pretty much the model is almost all set up. There's only a few other things I need to define. One is I want to define my hydraulic model. And to do that, I usually select this diffusive wave option. I'm not going to define any infiltration or evaporation or anything like that for this particular setup. And then we're going to just define our precipitation. So the precipitation, there's several options. I'm going to use a hyetograph, just a 24-hour. I'm going to do a 24-hour model here, type SCS type 2 24-hour distribution. This is the rainfall distribution over 24 hours. And I'm going to enter a depth. I think it was like 6.1 was like the 50-year rainfall for this area. And you can look that up online. There's something called NOAA Atlas 14 that you can find that value. Anyway, just hit OK here. And then I'm going to clean up my model. I'm going to turn a couple of these things off that I don't want to do. I'm going to clean up my model. What this does a bunch of things. Looks like I have an arc with adverse slope, so I must have missed one for some reason, but I'm going to leave it for now. We'll see what happens. And then I can save my GSSHA model. So we're going to make a folder called GSSHA here, and we'll call this Judy's branch. And save that out. And then we're going to run our simulation. Just going to run our GSSHA model. And this all looks good. And just make sure it's saving it to the right place. And it's going to run GSSHA. So that's the next thing. Now, GSSHA takes a minute to run. As long as it's successful, it will, after GSSHA runs, right now, so the default is GSSHA is only set up to create a file that has your depth, your water depth at every cell in my watershed. That's the default when you set up a GSSHA model. Now, if you want some other information, you can go to what we call the job control window, and I brought that up just for a second, but I can bring that up again after this is done, and we can look at some of the different output options for GSSHA. And there's a lot of stuff in the job control and a lot of stuff that GSSHA can output. And all that is available in the job control. There may even be some things that GSSHA can output that are not available in the job control, but you'd have to do that by editing GSSHA files manually if there's something that's not in WMS. Now, most of the things in GSSHA are in WMS, but there may be some things that are not. Anyway, GSSHA runs, reads the solution. In this case, all it's going to read in is this depth. So this is the solution folder. So it reads in this depth data set, what we call it. It's a data set. And what this is every point in your grid here. So we have this grid with all these cells. Every point on the grid has a value for different time steps in your model. And WMS reads all those values in and stores them as what we call a data set in WMS. And so we can show contours for that data set. I'm going to display color fill contours. And we're just going to scroll through here and see what happens. And actually, let me just change one other thing. We're going to change it so we only display any depths above 0.01 meters. And that should be good. Let's see, so depth. I'm not doing something right. Maybe I need to turn off. Okay, I think I have it right now. Let me just go to depth. We're going to scroll through here. I think I'm color filling these polygons. Let me just go and turn off my color fill polygons. So I have this polygon that represents the boundary of my watershed, and I was filling that polygon, but I don't want to do that. So so you can go through these time steps, and for each time step, as I kind of arrow down on these time steps, you can see the water depths on the overland flow grid as I step through there in my model. So that's kind of an overview of GSHA. And like I say, it reads that depth solution. If I want to look at other stuff, I can go to the job control, output control, and these are all the things you can output on the grid, this 2D grid. And then you can also output all this stuff on what we call the link node. They're called link node data sets, and that's just on my stream. So if you've ever run HEC-RAS or something like that, you have a water surface elevation on your stream. Well, that's kind of what this is. Link node data sets are just the water surface elevations or the channel flows, the channel depths. Let's see. Yeah, so here's channel depth, channel flow. You can output that, but to do that, you have to turn those on, then run GSHA again, and it'll output that information. The other thing that's output is this hydrograph. And so the hydrograph, you can just double click on that. It brings up this plot that shows your hydrograph at the outlet point for that watershed over time. And so that's pretty much all I wanted to show you. Probably ought to move on to the next person. I think I took too much time.
All good. Thank you, Chris. That was great. That was the 20-minute version of about 3 hours of classes from other times. So if you didn't catch everything all at once, no sweat. The GSSHA tutorials YouTube channel has a lot more of the detail so that you can go in depth and sort of much slower pace walking through the tutorials that Chris just sort of lightning round went through. So thank you, Chris. Appreciate that.